As we start, let's talk first thing, we're going to talk a lot about tools that you can use and the visuals that you can use as well. But I want to start here with what happened right where we are 1 week ago. The flooding that we had, the historic flooding here in Harlingen, it impacted the community. The water's still there. Some of us had to reroute trips because of it, right? And I was watching some of the coverage about it. This is the gauge there for the creek that runs through the city. And it was one of those moments where they said, this is one of those things where it rose really fast and it's never been to this level before and we don't know what to expect because we've never seen this before, right? We've seen that time and time again. So all said and done, we had almost 2 feet of rain that fell here across South Texas. The good folks at the National Weather Service issuing a flash flood emergency in a particularly dangerous situation that went along with it. So what do we know about rainfall when it comes to a warmer world, a world with climate change, right? The basics that we know, physics tell us that a warmer atmosphere is a greedier atmosphere. It's for every 1 degree Fahrenheit of warming, the Clausius-Clapeyron equation tells us that the atmosphere could hold on to about 4% more moisture. So if we're holding on to more moisture, we're taking more from the ground, we're taking more from the ocean. That also means that we can release more moisture, right? That's the general trend we've seen. The other thing that Climate Central has done last spring, at the end of spring, we used what is current weather and we used with climate change what inland flooding could cost. And down in Cameron County, we know that there was a very high risk of $20 million or more. We didn't know exactly when that would happen, but we knew that this was an area that had a very high flood risk on hand. What was kind of jarring about this release as well is the places in the United States that had the highest risk. We put that release out in May. And one of the places that had the highest risk in all of the lower 48 was the Appalachia region. And then we saw what happened, and we'll talk more about that here in a bit. But then let's look at the weather part of it, right? So this is the setup. I grabbed this a little bit after the event, but you had high pressure off the east coast of the United States, and we look at the moisture transport. You see that it comes from the Caribbean across the Yucatan and through the western side of the Gulf of Mexico. This is where we're feeding the moisture that goes into the weather pattern that we saw. And what we know about the waters over the Gulf of Mexico late last week where they're about 3 degrees Fahrenheit above average. And we know that with climate change, that a temperature like that is at least 6 to 10 times more likely to occur because of climate change. It has a fingerprint of climate change. Now, that bin goes from 0 to 1,000. We'll talk more about this tool here in a bit. It doesn't seem like it's that much. It's only 6 to 10, but you got to remember the ocean, it takes a lot to change the water temperature. So even a 6 to 10 times more likely is pretty significant. Now, all that to be said, I've shown you a tool here that you have no idea what it is, but I take that from my tech team that I get to work with now when I go with crazy ideas, and they're always like, no, tell me the solution that you want first, and then come back and backtrack and tell us how you want us to get there. So let's talk about this. We'll talk about hurricane attribution. We'll talk about the storms, the science of it, and the storytelling. If you're not familiar with Climate Central, we are a non-advocacy nonprofit. We do the science and data of weather and climate change. We're really good at that, but what we do with it is we give it to meteorologists and journalists and content creators like you. You're really good about knowing your community, telling the stories around it. So we get the data, we give it to you, and then you can tell the stories. So let's tell a story. This is what I tell my kids every night before they go to bed to make sure that they go to sleep. How many of y'all know what attribution science is? Couple? Okay. How many of y'all are really good at talking about attribution science? Couple? Okay, good. All right, so let's tell a story. Once upon a time, there was a scientist. He walked out of his door. He said it was a little warm outside, and he said, I wonder if this is part of climate change. So he started working on that. He got other scientists to come along, and at that time, it was always said that no one weather event could be called climate change. We just couldn't do that science. But then the science evolved. More scientists got along with it. So now we can quantify, measure, and understand in the moment that climate change plays a significant role in shaping many of these events. But a lot of the science that was being done was done really slow and meticulously. So maybe a big event would happen, and then a year later we would come back and we said, okay, we know that this % of that event was climate change. But because we're humans and we have the brain of a tiny peanut for the most part about what's happening, a lot of us have already forgotten about that event. So the science evolved, and we were able to do that rapidly. And as we get better and better at this, and as the science continues to evolve, now that did the climate change cause this dragon has been slain, we know that we can understand that climate change has altered or changed the risk, and with that knowledge, we can live happily ever after, hopefully. I showed the slide to my wife, and she was like, that's really dumb. And I was like, that means that it's really good, so thank you for that validation. All right. Extreme event attribution. So what we're doing here is we're not saying that the flood event last week was caused because of climate change. It would have rained here in South Texas regardless. We're not saying that a hurricane was made because of climate change. We know that a hurricane would have happened regardless. But what attribution can do is it can answer the question of how likely was this event? How much more frequent is an event like that possible as we continue to warm the planet? And what was the change in intensity or severity that came along with it? I just came back from a conference right before this one with the National Academies, and they're talking, it was a workshop to talk about attribution science. What can we say? What should we say? How should the science evolve? And what I was trying to tell them is that for the public, for the public, good and timely holds immense value over perfect but late, because they were talking, some of them were saying, we shouldn't do this until the models are absolutely perfect. But what we learned from Brian yesterday was that a model's not always perfect, right? We all know that as meteorologists. So for the public, being able to answer that why in the moment with the good science that's peer reviewed that we have, that's helpful. So the way that we do it with Climate Central, we have a tool called the Climate Shift Index. This is the Climate Shift Index for air temperature on the I guess your left-hand side there, for today. So what you're looking at, and again, this bin only goes 0 to 5. The reason being is that the air temperature changes quite a bit. It's easy to do so with the front. So we know that the above average temperatures, I keep hitting the wrong button, across the eastern and southern United States remain anywhere from 3 to 5 times more likely. So there's a strong fingerprint of climate change for April 2nd, or what's today, April 4th, to as much as 5 times as likely, which means that a temperature like that likely would not occur without climate change. It's almost virtually impossible. On the other side, though, when you get to the Rocky Mountains and the foothills, you get the gray color on the negative side, meaning that if you like a day like this in April in that part of the country, in a warming climate, we know that those days are becoming more rare. So then we can do this as well with sea surface temperature. So we call it the Climate Shift Index Ocean. That bin goes 0 to 1,000 because, again, it's hard to change the ocean's temperature rapidly. So the fingerprint, the heartbeat there is longer. And that's what we're going to use when we talk about hurricane attribution. So late last year, the science that we created using the Climate Shift Index Ocean, which is peer-reviewed, then became peer-reviewed for hurricanes. And so our scientist, Dr. Daniel Guilford, went back and looked at every hurricane in the 2024 season. And what we found is that every single hurricane was impacted by climate change with the sea surface temperatures alone, that it boosted the intensity at least one category. Meaning that with this science, we know that, again, we would have had hurricanes, but there would not have been a Category 5 hurricane in the 2024 season had it not been for climate change. We'll come back to this and we'll break this down more in a bit. I want to talk about just the science of it first. So first thing is that I started with a different quote, but last week when I was mowing, I listened to a podcast with NPR's Planet Money, and it was a collaboration with Radiolab. And basically it was around economics. It was asking, can the economy grow forever? And what they were talking about is the natural resources, how we're using them. Are we using them too fast? It's just like a human race. And are we using things on Earth? And it talked about moments of swerves, right? So it looked like we weren't going to be able to have enough resources to do this thing, and humanity wasn't going to be able to continue. And then at the last second, we steered the car from the cliff, we swerved, and we figured out a new way, right? So when we started talking about the things that are powering the lights above us today, part of it at least, and the things that we know that are responsible for climate change, this came up. It's harder to sell people and tell people that we have too much of this thing that's helping your life go on and on and on, but it's going to hurt you, as compared to we don't have enough of this thing, so take care of it. And I think about when we try to tackle that problem, we can use attribution science for that. So one thing to know when you're talking to your viewers, your audience, the Yale Program on Climate Change Communication every year since the early 2000s has done this study to look at the American mind and how they view climate change. What you know is that you hear from a vocal minority when it comes to climate change. 72%, 74% of Americans know that climate change is real and that it's happening. 59% of Americans understand that humans are mostly the cause. So for the most part, the American public understand. And when you look at the map, all the blue colors are going to be the states that are below 50%, and all the orange and yellowish colors are those that are above the 50% threshold that agree that humans are the cause. Now, don't tweet this part because this is still preliminary, so let's call it embargo, but they let me use it. This will be coming out a little bit later. But this year they did attribution. They wanted to know, can you connect what's happening in terms of extreme weather with the fact that climate change plays a role? And what we know about climate change is that people experience climate change through extreme weather events. Either they are personally living it, like we did here in South Texas last week, or they're seeing it on screens, on their phone screens, right? And I wanted to pull out two things. One, the way that most people experience climate change is through extreme heat. You can see the map there on your left, and then hurricanes. I want to talk about that. So 58%. So one thing where everyone falls above the threshold is going to be along mainly the East Coast, South Texas, right? These are places that are historically hit by hurricanes, places that are not hit by hurricanes, that you don't have to deal with that extreme weather, the middle part of the country. You don't make that connection because you're not living it, right? So let's break it down to Texas even further, places that get impacted by hurricanes, which, by the way, 57% of adults in Texas know that there is a fingerprint of climate change when it comes to the intensity of hurricanes. Harris County is at 60%, Galveston County is at 51%. What I think is really interesting, Chambers County, Orange County, way down in the 30% range. One of the reasons why, if you think about it, what's the main thing that people make their money and make their living for in those counties, right? So that's one of the things that we understand. And then when you get to South Texas, again, there's a pretty good understanding that climate change at least has some sort of role in shaping hurricanes and hurricane intensity. So let's talk about the science of it, right? The way that we do this, and again, this is peer reviewed, so we know that it is widely accepted as a way to do it. We understand that there are other things that impact hurricane intensity and that hurricanes are dynamic, but we also know that sea surface temperatures are a big part of what fuels hurricanes. So the Climate Shift Index quantifies the influence of climate change on those sea surface temperatures, specifically indicates how climate change has been influenced daily by climate change. We use 13 climate models, each of which is run two ways. One, as it would have been before the Industrial Revolution, and then the other way is with the historical emissions that we as humans have put into the atmosphere. So what we're doing is we're taking a ratio of those 13 pairs of simulated climate models, which are built from observations from OISST data, from NCEI, and then the CMIP6 for the climate modeling of it. We take that ratio, and then what we can know from that is we get these red colors. And I specifically pointed out the Caribbean here. Right now for the latest that we had, usually, by the way, because it is OISST data, it's always going to be at least 1 day behind because we have to get that data, so whenever it comes down. But I pointed out the Caribbean because for the longest time last summer, that spot in the Caribbean was like 800 to 1,000 times more likely to be anomalously warm because of climate change, and it didn't move. And if you look at temperatures, air temperatures for the Dominican Republic, for Jamaica, for Puerto Rico especially, their air temperatures, like they've just been seeing well above average temperatures. And we know that there's a feedback loop there, right? The warm ocean temperatures and then the warmth that they're seeing on the island themselves. So how do we use this? Before we had our hurricane science peer reviewed and we were ready to be able to say confidently we know, we were able to use it for Beryl, because Beryl came out of the gate and he came screaming on through to the Caribbean. So the area that Beryl underwent that rapid intensification, we were able to use this as a moment to connect climate change to the storm and to that why, as everyone was looking at it and saying, why did this happen? So what do we know? That it rapidly intensified over waters that were 2 to 3 degrees above average, temperatures that were more expected for September, late hurricane season, than June. We all knew what was going on with the water temperatures in the Atlantic last year. And we know that climate change made these temperatures 100 to 400 times more likely. So we know that the waters that are influencing and that Beryl is feeding off of were made more likely because of climate change. So what that means is that a temperature like that in June is 100 to 400 times more likely in the future to continue there, right? We'll talk Helene, but before we start, after Helene, I was sitting on a call with Covering Climate Now, and it was for meteorologists and journalists in the Southeast. Like they had just gone through this massive storm, and then, it was kind of like a just come, talk, ask questions, tell your stories. And a reporter from the Miami Herald was like, I'm tired of covering these stories because it always feels like the same thing. We see the storm coming. We know that it's going to do really big things. We know disaster's coming. We warn for the disaster. The storm hits. We talk about the aftermath. Wash, rinse, repeat. Attribution science is that new element. It can kind of give us that new little tool. So what we're able to do, we put out what we call climate shift index alerts. And before this was even named Helene, when it was still a potential tropical cyclone, we all saw the forecast and we were all in pretty good agreement that there was going to be a pretty significant increase in intensity as it came from the Caribbean into the Gulf of Mexico. We also knew that those waters were made anywhere from 100 to 500 times more likely because of climate change. That's because of how warm it was. So what we were able to do with that is use that information to connect it with the general public. We have a KML file, I'll show you how to download that in just a bit, that goes straight into your weather systems. But what you can do is you're analyzing these storms, you can help answer that why. Why is the storm rapidly intensifying? Why are we worried about this one becoming so strong, right? This is that extra piece. So when you're talking about sea surface temperatures, you're talking about tropical cyclone heat potential, you're talking about all these things that are feeding the storm. You can use this to help make that connection. One thing I think is important, because everyone always, they ask like, when should we use this? How should we use it? Obviously, if there is a hurricane that is about to make landfall in your community, you're not going to stand up there and say, climate change is the reason that this is happening, right? But what this is helpful for is as the storms still weigh off and the possibility of it coming into your community, it helps to make that connection for someone who thinks, oh, I can handle this. I can stay here and ride the storm out. To make that connection and say, hey, this natural disaster was made unnatural because of climate change. And that means that we could see bigger impacts. And if you're covering it from afar, because people will still have questions and they'll have interest, you can help make that connection there as well. So that's what we do in real time. We call that rapid attribution. And then right behind us is an organization called World Weather Attribution. And what they do is they look at storms and big systems and flooding, heat waves, usually in countries that are being impacted by climate change that aren't the main cause for climate change. But they looked at Helene, and what we know is that rainfall events as severe as these now occur once every, on average, 7 years, so about 3 to 25 years for the coastal region that Helene hit in Florida, and about now on average every 70 years, so 20 to 3,000 years is kind of the hopefully it's a 3,000, but for the Appalachia region. And we know that climate change made the rainfall 10% heavier, and the 2 to 3 day maximum that we saw up in the Appalachia region were 40 to 70 times more likely. So now we know how climate change impacted this storm, but that doesn't do us any good. The storm's already happened, right? So what's the point of this? To plan for our communities to build better, stronger, to know that this can happen again. So we know that a world with 2 degrees warming, that would tack on top of that another 15 to 25% more likely for rainfall to be heavier. And we know now that a storm like this on average could come every 53 years or so. What's really interesting about this science is we're able to make the connection, right? We're answering the why for the public. So the lines I want to show you here, these are articles that mention climate change with each hurricane. So Helene's going to be in the yellow. You see Helene coming, the media mentions kind of come up. This spike right here is when we're able to say, yeah, we know that climate change has an impact on the sea surface temperatures impacting Helene. The second big spike that you see here is when all the videos and images started coming out. Again, people wanted to know why. Is this weather, or is there an aspect of climate change? We also see this big spike here. Remember, we're a non-advocacy organization, but we see this big spike here because we start getting social media tweets that are saying that Helene was geoengineered, and all of a sudden it just pops up on our radar, right? So these are journalists trying to say, no, that's not true, but what we do know is that it was a little unnatural because there's an element of climate change. And then this big spike right here is that world weather attribution. But then when we get to Hurricane Milton, everybody's hyper aware of what's happening, and Milton undergoes that extreme rapid intensification in the Gulf of Mexico. And now people already understand that there's an element of climate change to the story, and well before it even makes landfall, the stories that connect climate change to Milton are huge. And what we knew with Milton is that the waters that it made, that it extremely rapidly intensified, and some of that's thanks to John Morales and that very real moment that he had on TV. But we know that that area was made up to 800 times more likely to be that extremely hot at that time of the year in that part of the Gulf because of climate change. What is interesting about Milton, does anybody know where the OISST data originates from and gets disseminated from? Asheville, North Carolina. So NCEI was knocked offline because of the flooding. So we actually couldn't use OISST data to do this analysis originally. We had to switch it to OSTIA data and make that our engineers stayed up all night to recode to put that data in there so we could help make that connection. Okay, so then at the end of the season, we were able to say this. Again, every hurricane was bumped up at least one category in intensity due to climate change. as much as 800 times more likely. That was with Beryl. Temperatures were warmed as much as 2.5 degrees Fahrenheit. And we know major hurricanes like Helene and Milton were added about 16, 17 miles per hour and 23, 24 miles per hour, respectively, to their intensity. So what we're going to be able to do by the summer this year is that now that hurricane attribution is peer-reviewed and is widely accepted, we'll be able to, in the moment, give you understanding of the lifetime maximum intensity. So I want to pull out Hurricane Oscar. Anybody remember Oscar from last year? Just a wee little guy. The Hurricane Center was watching it and had an area of interest, and then they dropped it. And they said no development, 0% chance for development. And then all of a sudden that morning, it went from a disturbance to a tropical storm, and then all of a sudden it went to a Category 1 hurricane, right? It was stronger than we expected. So what we know with Oscar is that it went from that disturbance to a Cat 1 hurricane in 12 hours. It reached a maximum lifetime intensity of 85 miles per hour. Climate change, those warm waters that it overwent there as it headed towards Cuba, added 9 miles per hour over waters that were 500 to 600 times more likely to be 1.5 degrees Celsius warmer than they would have been in a world without carbon pollution. 9 miles per hour doesn't sound like a lot, but it's that little extra wind, and even half a category can double the amount of impact that you see on a coastline. So that's why this is helpful, right? It's not the whole reason that Oscar was able to do what it did. It's not the reason that it became a hurricane or a tropical storm even, but it added extra to it. So some of the proven language that you can use with this is, and we know through attribution science that climate change has made a temperature of this as much as this times more likely. That's how you can quantify it. You're telling your viewers, you're telling your audiences what the science is. Again, half a category boost is about twice the damage that a storm could have produced. A category boost is about 4 times the damage that a storm could have produced. And then one thing that Dr. Daniel Guilford was telling me, he's like, there are people who talk about, the idea of warming in the atmosphere, and we've talked about that together, but there's more instability associated with the sea surface temperature warming than there is added stability because of atmospheric warming that happens. So real quick, I want to, if you hit play for me, this is Steve McLaughlin. He is in Miami, and he did a recap of the season. I want to show you how he uses science.
2024 will be Earth's hottest year on record. When we heat up the planet, we heat up the oceans. And when we heat up the oceans, hurricanes become much more dangerous.
The analogy I like to use for us is that it's kind of like an extra shot of caffeine in your coffee, right? Like we all need that coffee to get up and get going in the morning. For a hurricane, the caffeine for the hurricane is those nice warm ocean waters.
This is the Gulf of Mexico on October 7th, and that is Milton. Our friends at Climate Central used their exclusive Climate Shift Index to conclude that those scorching Gulf of Mexico temperatures were at least 100 times more likely because of human-caused climate change. And that, in turn, turned Milton from a Category 4 to a Category 5 by increasing the wind speeds by 23 miles per hour.
The likelihood of a storm intensifying from a weak hurricane into a major hurricane has more than doubled just since about 1971.
In addition to Milton increasing by 23 miles per hour, Climate Central also concluded that climate change increased Helene's winds by 16 miles per hour, making it a Category 4, and Beryl's winds by 18 miles per hour, making it a Category 5. But peak winds alone are not the scariest aspect of climate change. It's how quickly we get to those peak winds. We call that rapid intensification.
In the most recent kind of 20-year period I looked at, say from 2001 to 2020, a modern period, we have storms reaching peak intensification rates that are up to 28% faster than they were in, say, the 1970s and 80s or a historical time.
Rapid intensification is defined as a wind increase of 35 miles per hour in 24 hours. What Milton experienced was what's called explosive intensification, going from a tropical storm to a Category 5 monster in 24 hours and ultimately peaking with winds of 180 miles per hour.
So we know that rapid intensification isn't anything new. We know that's a process that hurricanes can do, but we also know that it's something that we've seen more and more as we've seen warmer oceans. And this is just a side note. We have graphics for you that are on our resource page that it detail, the trends that we've seen in rapid intensification, extreme rapid intensification, and also, by the way, all of our resources that we have around hurricanes and everything else is also in Spanish because that's important as well. So if you want to bring in that KML, this is the Climate Shift Index Ocean. When you go to the map, there's a download here. The reason that we don't have a link for you is that you want maybe a specific day to look at. But you can download the KML file for whatever day you're interested in, and then you can put that into your Max or your Barron system. Very quickly, Hurricane Hal showed these yesterday. We also have a program called Flood Vision. It's a forward lightning that has mapped the entire East Coast and Gulf Coast. With basically like a Google Maps card, but with LiDAR. And so what we can do, this is actually right outside of our hotel, just like steps away from where we are right now. We can use that to then take the different scenarios that have come together from NOAA in terms of sea level rise, and we know the local high tide, and we can do sea surge as well as just sea level rise imagery that comes with it. This is also available for your community if you're a coastal community. And one of the great things about it is to show people. So when they say it helps them understand. If you're saying there's going to be this much water, this really helps them see and understand what they're actually going to be dealing with. All right, so to wrap this up here, a lot of this is, again, it's making the connection. It personalizes climate change. It increases the understand for your viewers for what they're doing. It motivates action. Again, we're taking this natural thing, we're making it unnatural. There's a little bit of element there. But I think for what we've really seen with attribution science is it builds confidence. We can talk about trends a lot and just generally what we know, but this builds confidence to make that climate connection when maybe you wouldn't have. What's coming? We've got our hurricane attribution tool coming at the start of Atlantic hurricane season. Again, at maximum lifetime intensity, you'll be able to go and pick that up and get that information quickly. And we're also doing an inter-comparison research. We want to make sure that we're doing this properly. There's other people that are doing hurricane attribution, so they're actually going to all be working together using Milton to get together to make sure that everyone's kind of on the same page so that we're not all, one, putting out different information, making it confusing, but also two, to make sure that we're doing this responsibly and understandably. That QR code will give you all the links, all the resources that you need that we talked about today. It also has my contact information. One thing about what we do at Climate Central is that, again, we do the science and we do the data, and it is completely free for you to use. All of our imagery, all of our science is for you to use to make the connections. So feel free to do it, and if there's something that you can't find or something that you're interested in and you need a little bit of help with, my contact information is there. My job is to literally make your job easier, and I'm happy to do that if I can. Cool. Thank you all.